Hey guys, we are in chapter 8. We're looking at section 8.5, and what we're going to talk about today are a couple of concepts. One is constant rate of change, and the other is direct variation. So let's get started with our vocabulary. Today, our vocabulary, let me see if we can get that to come up. Our vocabulary includes 4 terms, and they are related, so they're not too, off topic. They're kind of together. So what we have is a linear relationship, and basically, this is a relationship. Anytime you have a relationship where the graph of it is a straight line. So if I were to have a relationship, let's say, remember ordered pairs show us relationships. So if I were to have x, y, if I were to have, let's say x is 1, y is 2, x is 3, y is 4, and so forth and so on, where they're 1 apart, you would see that you would get, if we were to graph that, 1, 2, 3, 4 would be up here. If we graph all of the points that would follow that rule or that relation, we would have a linear equation. So anytime we have a relation that comes out to have a graph that is a straight line, it is a linear relationship. All right, so let's go ahead and take a look at some other things. Let me get that out of the way as well. All right, so another concept that we're going to talk about is a constant rate of change. It's when the rate of change between any 2 data points on a relation are the same. A constant rate of change, you're always going to see a constant rate of change when you have a line. Okay, so what that means is if I take a line and I consider any 2 points on the line, if I consider the ratio of going up and over, remember we talked about rate of change was the change in y over the change in x. Doesn't matter what 2 points I choose, as long as I'm on a line, that ratio is going to be the same. So I'm trying to indicate that by doing different colors along this line. The ratio of the red length to the red length and the purple length to the purple length and the black length to the blank length will be consistent because it's a constant rate of change, right? If you go up 2, you go over 1, up 2, over 1. Sort of making sense? It'll make sense if we think about it this way. Let me show you another concept that we can kind of think about. So if we think about a straight line, as I mentioned before, a straight line is going to have a constant rate of change. But if we have something like this, a curve, the rate of change actually changes. The increase, and we've talked about this in 6th grade, I remember, the increase here is steady and slow, but then it increases here. So the rate of change between these 2 points will be different than the rate of change between, say, this point and this point, because the change in y over change in x is going to be a different ratio from here to here. I hope that didn't obscure the concept. So rate of change, constant rate of change is what we have when we have a straight line. Let's talk about direct variation. Direct variation equations are always going to be of the form y equals kx, where k, and this is going to bring us into the next concept, is our constant of variation. So y equals 2x is a direct variation relationship between y and x. And in this case, 2 would be k. So the constant of variation in this equation would be 2. I'm going to put down another equation. Let's say I had y is equal to negative 5x. If you notice in this situation as well, this is direct variation because the equation, let me erase this, fits the form y equals some number k times x. And in this case, that number is negative 5. So negative 5 is the constant of variation, the k value, and it fits the form. So what we'll see with direct variation equations, and this is something you want to keep in mind, direct variation equations are linear, but they always, always, always pass through the origin. Okay, so direct variation, one quick way to know if you have a direct variation relationship is if it passes through the origin and it's a straight line. All right, let's take a look at a couple of examples. This first example might seem a little bit involved, but I'm going to read it to you. A circle design on an internet advertisement has 2 circles, one that is decreasing in size while the other one is increasing in size. So you can kind of think of one, I don't know if that didn't help you. Okay, you can kind of think of one circle getting bigger and bigger over time as another one getting smaller and smaller. And what we have over here, we're going to find the constant rate of change for this radius of circle 1. And I realized I did not put circle 1. I didn't tell you which one was circle 1. I'm going to glance and see which one was supposed to be circle 1. This green equation referred to circle 1. Not that it matters, but all right. So this is circle 1, and this guy over here is circle 2. Okay, so our goal is to find the constant rate of change for the radius of the circle 1 in the graph shown, then interpret the meaning. So the constant rate of change requires us to take 2 points, find the change in y over the change in x, and it's constant because it's on a straight line, and that rate is going to be the same no matter what 2 points I choose. I see that this green line that represents the change of circle 1 has 2 points that are designated. So I'm going to pull those points out for us to think about. So this first point is 2, 5. And the next point that we have is, 6, 4. All right, so using our skills at finding the change in y over the change in x, we are going to find the constant rate of change. So the y values I'm going to start off with, and you remember I was doing this highlighting thing. I don't know if that was helpful to you guys, but I'm going to just give 2 different colors to our points so I can keep things a little bit organized. So when I look at this, I'm going to do purple 4 minus, and I have it in such a different color. So the purple 4 minus the 5, remember this is the change in y, over, and I have to keep my order, purple 6 minus the 2. So I did the change in my y's over my change in my x's, and I made sure my purple terms were always first. Okay, so now I have 4 minus 5 is -1, 6 minus 2 is 4. So my rate of change is -1 over 4. What does this mean? So we found it, yay, but the question is interpret its meaning given the situation. So the change, what we see is we have a decrease of 1. Now this is the radius of the circle, that's in centimeters. For every decrease of 1 centimeter in the radius, that happens over time 4 over 4 seconds. So the interpretation is for every decrease in it takes 4 seconds for a decrease in the for 1 centimeter decrease in the radius. Okay, let's take a look at example 2. So in example 2, we are looking at another situation, and this one, let's see if I can fix something here. Okay, I was missing my line on that one, so we should have a line that's coming from the origin, going through the following points, and it is a straight line, though my hand is not as straight as I want it to be. It was a little crooked, my apologies, but this is a straight line. So the graph shows the cost of different amounts of trail mix. Determine if there is a proportional linear relationship between the cost and the weight of the trail mix. So in determining whether or not we have a proportional relationship, what we need to do is see if every ordered pair that we can see here, if the ordered pairs here will create a constant relationship. So what am I talking about? I will tell you, darling. So here we have this point right here is 414. And then this point right here is 828. And this point right here is going to be 1242. So I found some common points. And what I need to see in this one is 0, 0. Okay, so what I need to see is if for any x value, there is a y value that I can get simply by multiplying x by a number. I'll say that again. So if y is equal to some number, this is kind of like direct variation, by the way. This is direct variation. If y is equal to k times x, and that's true for every point, then I know that I have a proportional relationship. So let's take a look. Let's choose this first point here. So I'm going to put 14 in for y, k in for x, and I'm going to put a 4 here. If I had to solve for k, I would get that k is equal to 14 divided by 4. Or better, I'm going to reduce this and get 7 over 2. So what I want to test and see is that going to be the same thing if I were to plug in any of these other points into the equation. So when I do that, I have 28 here is equal to k times 8. When I divide both sides by 8 to get k by itself, look at that. 8's divide here, 28, 4 goes into 28 7 times, 4 goes into 8 2 times. Again, I get 7 over 2. And since this is a linear equation, I can bet that this is going to have that same relationship since I've seen it happen so many times before. But just for kicks and giggles, let's do it again. Y is equal to kx I'm going to test and see if this K value is the same as we've had all the time. So Y in this case is 42. K is what we're looking for. We're going to multiply that by 12 to answer this question. To figure out what K is, we're going to divide both sides by 12. When I look at this, I think, I know that 6 goes into 42 and it goes into 12. How many times does 6 go into 42? Let's see if I can make this work. It goes in there 7 times. And how many times does 6 go into 12? 2 times. So I see that that relationship is the same. So in a way, I can also say Y over X is going to give me some K constant value. If I have this for every Y over X point in my graph, then I know beyond a shadow of a doubt that I have what we call a proportional relationship. And as I said before, proportional relationships are also direct variation relationships. And we're going to see that in this next example. So we're going to use direct variation to solve the problem. The time it takes to burn amounts of information onto a CD varies directly. So they're telling me that this is a direct variation situation. As soon as I hear that, I pull out of my back pocket Y equals KX. Okay, so they're saying, hey, the data here is going to fit this form. And okay, information on a CD varies directly with the amount of information. So here is our table. Our table is here, and I just wrote down the question here. So the first question, there's 2 parts. The first question is we're going to write an equation to represent the data in the table. And so here's the data in the table. We know that this equation is going to take this form. What we basically have to do is figure out what K is, figure out what that constant of variation is. And in order to do that, remember that last problem that we had? When we have a proportional relationship or a direct variation relationship, there's going to be this really nice relationship between Y and X. There's a constant value K that I can always multiply X by in order to get Y. Well, that's what we have here. So let's go ahead and exploit that a little bit. So if Y is equal to K times X, in this case, Y is 10, and K we're looking for, we're going to multiply by 2.5. In the last equation on the last page, I also mentioned that since we had this relationship, we could also write Y over X is simply equal to K. And so when I do that, I get 10 over 2.5, which is what I do if I were solving over here. 10 over 2.5 is equal to K. Obviously 2.5 goes into 10, pardon me, 4 times, and you'll see that that's the relationship here. So 4 times 2.5 is 10, 4 times 3.75 is 15, 4 times 10 is 40, 4 times 25 is 100. So it doesn't matter what ordered pair you choose if you know you have a direct variation situation. All right, so with that in mind, we've got this value. So let's write our equation. Our equation is Y. So for the time, Y is time in this case, for whatever Y amount of time you have, you can get 4 times X amount of megabytes of information onto a CD in this amount of time. So that's our relationship here. Let's look at the last part of this. It says predict how long it would take to fill a 700 megabyte CD. So if Y is time, I'm looking for Y. I already know what K is because we found it for this situation, and we said that we're dealing with a 700 megabyte CD, so I'm going to put my 700 here, and of course I'm going to just follow through with multiplication, and I get Y is equal to 2800 or 2,800, and in this case we were talking about seconds. So that's how long it would take for a CD of that size to be filled according to this plan. I hope this made sense. So just a real quick recap, I want you to recognize that proportional relationships are direct variation. The constant of variation is that K value that we're looking at in the Y equals KX form. These are kind of big words, but the topics aren't that deep. Don't feel like you have to go it alone. Let me know if there's something that I can do to help you. I look forward to seeing you tomorrow. Take good care. Bye-bye.